Hey guys, what's going on? Welcome back to the channel. On today's video, we're going to be installing an EDT speedometer onto the golf cart. Now, I'm doing this so I don't have to use my phone and use applications and make sure the applications are staying lit and make sure the phone doesn't go to sleep and all of that. Plus, this tells us so much more than a lot of the applications out there. Stay tuned. Alright, I have all the contents laid out on the back of the golf cart here. Everything that's in the box is down below as well. The first thing you notice inside the box is your user's manual. This is going to cover everything from A to Z. Everything from installing the battery that's inside of this right here, EDT speedometer, to mounting this right here, to hooking everything up, and to programming everything. What's great about it is not just words and diagrams, it's lots of pictures as well. So be sure to check this right here out and look through this thing thoroughly before you install your speedometer to your golf cart. The next thing you'll see inside the package is your EDT speedometer. It's going to be in a piece of cardboard, and inside that piece of cardboard is going to be your speedometer cable. Now this bracket here is included with it. It's going to have all your hardware to mount everything to the steering column. This right here bracket is 6061 aircraft aluminum. It's been CNC'd, and I'm going to show you how to install everything here in just a second. And you're going to have a bag of hardware to do all your installation. You're going to have your power and ground cable here. You're going to have your temperature sensor here that goes to the motor, and an extension cable for your golf cart, along with a piece of foil tape. This right here is to mount the temp sensor on the outside of the motor. And like I mentioned before, this right here is going to be your speedometer cable, and all the connections are JST connections, so everything's going to be watertight. So when you order your EDT speedometer, basically you're ordering it per bracket for which car you have. Now let's go over this. This right here is for my club car president. We're going to be installing today. And this right here fits the outside diameter of the steering column. This right here is for a club car that has a plastic sleeve over the steering column. These right here bolts will actually hold the mount in place so it doesn't clock or rotate while you're riding down the road. This is a U-bolt. This is pretty much a universal style mount. You have an upper mounting holes, a set of lower mounting holes for your speedometer to mount onto, and it has all the hardware. This would be great, say you have a side-by-side, a different type of vehicle other than a golf cart. This right here would work great on that application there. On this right here mount here, this is 5051 aluminum, and it has all the hardware to mount to your dash or inside of your dash. And you have your holes here and there to mount your speedometer onto as well. Now they make a bunch of different kits for a bunch of different golf carts. Let's say you have a club car gas or a club car onward gas or any other club car using the HD wheel hub. They got a kit for you. Say you got an Ezgo RXV with a short hub. They got a kit for you. Say you have a club car Villager, a 6 or 8 transporter, 6 or 8 passenger golf carts with the front drum brakes. Well, they got a kit for you as well. So if you got some oddball golf carts, you can also get this set up, and these instructions are very colorful throughout the entire process. Now on these brackets that are included with your kit, this is going to be the front side. You can always tell the front side because it's completely smooth at the top here. The back side has the indentions for the mounting bolts for the EDT speedometer. I'm going to show you how to put this right here mount together. If you notice here, these little rubber spacers here have an indentation in the middle. We're going to take those and mount them through the bracket. Might have to take a screwdriver or a little piece of, I'm using this Allen key here to mount mine. Once you have this right here mounted, that's going to stick off like so. On the back is going to be inside the indentation as well. So these red anodized spacers that are included with the kit, they serve a special purpose. They are actually a stop so the bolt doesn't go through and damage the EDT speedometer. Now there's a special way of installing them. You're going to take it, and the flat side here is going to go in the recessed portion of the back. So make sure that the sleeve itself of the anodized stop goes through the mount. Like so. See how that goes in there? If you look in here, that red anodized mount is inside of that bushing there as well. Next, we go ahead and take our wire harnesses here and push them through the mount. And once we have the speedometer in place, we use the supplied hardware to install these. And there you go, the speedometer is now installed. Now that we have the speedometer mounted onto the bracket, it shows us we have the 4 connectors coming out this back hole here, and we also have a ambient air temperature sensor for the air temperature on the outside, which is going to display on the speedometer as well. Now let's say you're using one of these mounts to install your EDT speedometer. The rubber grommets go in the holes the same way, front and back. These red anodized spacers always goes like this right here. You always put the flat portion towards the back. The sleeve fits through rubber washer right there. So the tools that you need to mount the bracket to the golf cart and the EDT speedometer to the bracket, we use a 2.5 millimeter Allen wrench for the back there, and we're using a 5 millimeter Allen wrench for the bracket mounts on the bottom. Now on the back of this X-ray speedometer here, you're going to have 4 connectors. All 4 connectors are separated into a different style, so you can't plug one into another. They only go in one spot. You're going to have 3 connections that's going to come with the kit. This 4th one here is going to be for an aftermarket remote, and that's to also control this right here as well, and I did not opt in for that remote. On the power and ground, I ran it to the switched leg for when the golf cart's on, but not when it's off. So with the golf cart turned off, my green wire has power, my blue wire doesn't. When we turn power on or the key switch to the on position, you should have power on both sides. We do on the green and we do on the blue. Now what's included in the kit is a ring terminal. You can take those bolts, one of those bolts out and put this ring terminal up underneath it, or the company supplies a piece of foil tape that you can secure the ring terminal to the motor with. So we have a piece of foil tape that is included with the kit. I'm just going to tape this right here onto there, just like that. Just rub it into place, make sure it's stuck all the way around. You can see there is an indentation right here of the ring terminal, so it is in place. Now we have the connectors right here. Now what I'm going to do is connect a wire tie around here and probably a wire tie back here as well. What this is going to do is give us enough slack that this is out the way, except it's going to give us enough slack that when the back axle is articulating and driving down the road, it's going to give us enough flex. All right, so now we went ahead and removed the driver's side front wheel and tire from the golf cart. We noticed the back of the hub here. In the owner's manual or the user's guide, it's going to have a couple of different hubs for the Club Cart President or Ezgo or Yamaha, and you need to make sure you're using the correct instructions per hub. So in this hub here, it's got an opening in the dead center at the top, on both sides and the bottom, so you have 4 different chances of getting this right. So per the user's manual, what we're going to do is to take a Sharpie and put something straight along the top of the 2 studs off the hub, and we're going to mark it with a Sharpie. Like so. Now once we have this right here marked, we're going to find center off of both sides. So we're going to take a measurement from here over and from here over and mark center. So this hub's about 4 inches, and we're going to make a center mark here on the 2. Now once we have everything marked and we know where to drill, we're going to take a 5 millimeter drill bit to drill us a hole through the hub. Now with that being said, if you don't have a 5 millimeter size drill bit, you can use a 13/64. Now what I'm doing is I'm lining up as well visually as with the line that I marked. And it looks like the line might be over just a tad, or it was actually on the left hand side of the 2-inch mark that I made. So now I'm going to take this drill bit and send it. So as you can tell, we went ahead and drilled the hole through the hub, and it's pretty much center. Now this is going to be the bolt that's going to be used to attach the bracket on the back to mount our magnet with. With that being said, as you can see, this was not going to sit flush inside the hub. We're going to need to take it like a little bit larger drill bit, and don't go all the way through, but drill large enough where this right here bolt will sit flush against the hub and the wheel. Drill bit that I have is going to be a 3/8 size. You might be able to get away with like a 7/16. Like I said, we're not going to drill all the way through, just enough for the bolt to sit flush inside the hub. Once we have that, we can test fit our bolt again. And as you can see, it fits perfectly inside the hub. Now, in order to mount the screw here through the hub, we're going to use a 3/8 or 10mm nut driver to hold the locking nut behind the hub. Now on the front here of the pan head screw, this right here is going to use a 2.5mm Allen wrench to lock it in place there. What we're going to do is to slide the bracket like this from the back. I'll go ahead and take this right here and give it a couple tight turns here. This bracket is now mounted. Now, in order to mount your magnet here, you need to put a jam nut on it first. And then we need to finish that off with a lock nut. Now, in order to tighten up this bolt with the magnet in it and this jam nut, we're going to use a 10mm wrench. Next, we need to tighten up this jam nut here. Now, these right here are tight. It's good to go. So this right here is the end of the speed sensor wire. This is the connector that's removable. This is a JST end here, completely waterproof. Now this right here bracket is the one that we're going to be using. It's very adjustable up and down. As you see, the end of the sensor has 2 jam nuts on it to tighten it up. Now, in order to tighten the 2 jam nuts on here, that's going to require a 9/16 wrench on both sides. Next, we need to go ahead and place the bracket on the spindle behind the hub, line it up, make sure it's about a 1/4 inch gap or less, and mount it with the ring clamp. Now, once you have the speed sensor lined up where you want it, you need to go ahead and tighten the ring clamp. Now, once we have everything mounted, next we'll go ahead and zip tie everything. I zip tied it to the top of the spindle here. I zip tied one to the top of the shock, or in the middle of the shock, and another one on the top of the shock frame there. I did that so it wouldn't get in the way of the steering column itself. All right, once we have everything installed, the wheels back on, we need to start the programming method. It's not automatically going to pick up the wheel and tire speed by the tire height. It doesn't know that, so we have to program it. Now, inside the user's manual, there's going to be 3 different ways of doing it. There's going to be method 1, the easy ruler method, method 2, the rolling measurement, and number 3, the distance measurement. Now, what we're going to do is the easy ruler measurement. So it says we have some 23 by 10 by 14 inch tall tires. Now, if we use that number there, we might get close to the calculation for the speedometer itself. So what I have here is I went ahead and put a level in place, and it's level as it is right there on top of the tire. Next thing I'm going to do is I'm going to take a tape measure, and I'm going to get my exact measurement. Now on here is saying I have a 24.5 inch tall tire versus what it says here as a 23 10 by 14. So we're going to take the measurement 24.5 and do some calculations. All right guys, so we know the tire is 24.5 inches tall, so we're going to put 24.6 We're gonna multiply that by 25.4. It's gonna give us 624.84. Then we're gonna multiply this by 3.14. And this right here is what we're gonna put into the place here. I'm gonna go ahead and round that right here up to the 2 spot. So we're gonna put on our booklet here, 1962. So my tire size is gonna be 1962. And we need to program the speedometer as well. Now we need to go ahead and enter this speedometer into data mode. We're gonna do that by holding all 3 buttons for 3 seconds. Once we're in the data mode, the first thing that's gonna start flashing is M-H. That's gonna be miles an hour. If you wanna adjust it to kilometers an hour, we hit the button here, it'll say kilometers an hour. I'm gonna go back to miles per hour and hit the mode button. The next thing is the tire size. Ours is 1964, so we're gonna leave the 1, go to the right button here, go up here, go to the right, go over. Our tire size is adjusted and in there. Now we can hit the mode button. So while I'm in post editing this video here, I noticed I put 1964 for the tire size on the EDT X-ray speedometer. When I went ahead and rechanged it to 1962, even though it was only a 2mm difference, I went ahead and changed it. Now we're gonna keep it on a 12-hour clock. Say you're like a military time hour, so you can go to military time or you can go to just regular standard time. Now it's 2:43 on the clock there, but once I look at my phone here, I know it's 1:53. So we're gonna go ahead and change this up here, go all the way around to 1, and then we're gonna go over here, one more, to 53. Now that's set. Now it says units. We're gonna leave this in Fahrenheit, but if we wanted to go to Celsius, we could go there as well. Now we need to set the temperature side, high, and maximum. In the book, it calls for electric motors, warning to be around 65 degrees Celsius, 149 degrees Fahrenheit. On the danger or the critical side, 75 degrees Celsius, 167 degrees Fahrenheit. So I got in touch with the guys over at Navitas, and we're gonna need to set the Navitas for around 100 degrees high. And 135 degrees for danger. Now what'll happen is when it gets to 100 degrees, this little light right here come on. If it gets to 135 degrees, this light right here will come on the speedometer. Now we're just going to set it by hitting the mode. Now we're talking about DC under voltage here. I don't know if the left here, that's going to be a yellow LED light. This is going to be a red LED light. The first LED light that's going to come on is the warning light. Since I'm running a lithium pack, I'm going to put my first warning light at 43. I'm going to put my danger light at 40. Now, if you have a gas-powered golf cart, you can change the oil at a maintenance time. Same thing with electric here. Now, since we have lithium, we don't have to worry about filling the batteries. But if you wanted to fill the batteries a certain, miles or whatever, you just need to go ahead and enter them now. Now, at the top left of your screen here is going to tell you the speedometer, miles per hour. This bottom left, it says high voltage. That's because the golf cart battery is above 52 volts. Once we start going, it's going to drop down. This is the motor temperature of 67 degrees Fahrenheit. This is the distance traveled and time, and we have a run time total. If we hit the mode button here, you see the air temperature in the garage is 79 degrees Fahrenheit. Now we went ahead and set the Navitas all to the factory settings, and then we can go ahead and monitor everything on the speedometer. And when you're going slow, it's not going to read right, like under 2 miles per hour. But once you start getting above 2, it's going to start reading. Sorry guys, off that last little run here, it says we went 3/4 of a mile. It's got our time. It's got run time here. It says the motor's around 74 degrees Fahrenheit. Our battery pack's at 52.5 volts. And right now the speed is 0 because, well, we're not moving. Let's hit the mode one time here. Air temperature's 79 degrees Fahrenheit. Battery's still at 52. Max speed was 28.1, the average is 9.5. It's good to know. This right here would be great for an LSV vehicle, or a vehicle where if you have an aftermarket controller or a motor, but you don't want to use your phone to monitor everything, this is the go-to method. This is the back of the Navitas controller. What I'm doing is I'm going to take a piece of tape here and I'm going to put it on this billet bracket here, or this aluminum bracket. I can measure out my holes a lot better there. Once I have an awl, I'm going to take an awl and poke them holes in. Then I'm going to pull the shear tape off, put it on the back of my bracket, drill those holes. That way I can go and get my bolts in the right spot to place my controller back onto here. So I'll mount this right here onto the bracket, and once I have it on the bracket, I'll go ahead and mount the Navitas controller back to this back panel here. Pretty simple, if you can follow along what I'm saying there.